the proposed, like, if they're confirmed, they're still like proposed, in my opinion. They're kind of loosey goosey with the rules sometimes.
Okay.
One big thing is currently data collection. It was basically proposed or like instated that data collection was going to be, anything you collect in these two practice sessions that they're going to have or like on the track. You can collect as much data as you want, and you can use that data however you want. However, when we were talking about it in the meeting, it kind of turned into whatever data you can get your hands on before the competition, go for it. So I can get into contact with Purdue, and they offered, just in general, they offered to share their data of the track to people. So like we could get camera data and things like that, LiDAR data for um, the actual Purdue competition track. Um, that's something that's very possible that you can actually get your hands on. That would be great. Um,
But you still change program ahead of time the track comes on.
Not the race that we're currently in. It's a specific race.
well, they've actually you could
Maybe not.
so they're merging
Yeah.
the yeah
That's confirmed.
Terrible.
yeah
Okay, so just one. So some of them will have that, and some
So here,
no yeah
no, just go on. No, give us Ben. More Ben.
um yeah my understanding is that there's only one category, which is basically just everything goes. Uh, and a part of, not the whole competition, a part of the competition will be side by side racing with two parts. Just a second, but object detection or object avoidance has been removed. So these boxes, as a rule, are out of there. But yes,
So there's one
So
race.
that's like a half of a
Let me rephrase. So you said it's only one part of it is the two.
it's a part of the competition.
So there's a part of it that's
Yeah.
just time trial.
Yes, most of it, like I would say, and I've talked to Andy a little bit about this. Basically, we're just kind of gonna ignore the side by side stuff for now. Just staying still. Like we don't want to, in the middle of the year, go, we got to add these four features to our cart. That's gonna end in disaster. So basically, we're just gonna stick with, can we make it around the first turn? Um, but all this stuff is kind of, we'll see where it goes. One minor rule change is there's going to be a minimum weight requirement to the cart.
What is that?
It's going to be, I believe it's 250.
So,
Where's mine?
or 200, wait, I mean 150.
Yeah. If it's not that, it's 350.
Perfect.
But we're still under that.
Planning.
Yes, yes. They did give us some recommended weight distribution, so we could figure out. I think it's 43% front, and then to 57% back, and then 50/50 left to right.
If you could find that.
Yeah, yeah. I mean, he hasn't actually. This is all what I'm remembering from the meeting. He hasn't actually sent out the document.
Okay, that means it's going to be a document.
There's going to be a document that he's going
And
to.
is there going to be open discussion about whether or not it's something you actually want? Or yeah.
It seemed like it was just pretty much like this is it.
So nobody else gave their input.
Nobody else. Well, people did give their input, but not really on that. That was just kind of, everyone was like, okay, you're removing object detection or object avoidance and adding this. Or I mean, like, my understanding is this will just kind of replace that.
Okay.
You know what I mean?
Well, the reason that sucks for us is
Yeah.
it would be nice to do object avoidance, but if they get rid of that and they said jump to all like cart avoidance,
Mhm.
I mean a whole different ballgame.
Yes.
I
I think that they are accelerating the rules a little bit too fast to their goal. Their goal being a Grand Prix, everyone's racing side by side, and that's like the main event. I don't think the competition's there yet, but I don't know. We'll see how it goes. It's their controversy. I'm trying to remember if there's anything else major. one of the basic ones where it was for safety, which is when a track is running in competition, or when a cart is on the track, everyone has to basically be completely off the track, off the grass, also around the track, and
Oh,
by the
so even testing.
Oh, there.
during testing as
So
well.
no one can be on.
Yes.
That's a big change.
So that's good, right? I mean, it's to say that you don't have to slow down if you're losing your life.
It's kind of good, but kind of bad because during comp,
Our
there were like 3 carts on the track at all times, and everyone's testing, everyone's doing their thing while.
and then like carts go off the track, and we have to like push them or pull them or
Yeah,
pull
we
them
have to
off
like
back
we have
up
to
the track.
move to let other carts go by. But if this is happening, then
Yeah.
only one cart can go and do their thing. So it's gonna waste a lot of time that we can actually like, test it on the track. That's so
But
it's
we
good.
could also potentially get Purdue data and literally train our AI models on.
I don't know.
You know what I mean?
So,
No, we might be able to get a lot of that value out of testing.
yeah.
And,
Either way, it would be useful, even if it's just for testing our detection stuff.
yeah.
You know what I mean? So that would be like that would be
Yes. As far as the most important things, I think that pretty much covers it.
Okay.
I will read through the document when it comes out tonight, and if there's more stuff,
Yeah.
I'll let you guys know. Through this one.
Well, thank you, Zane.
Yep.
For those of you who don't know, I am Derek. My role is chief engineer of Phoenix. So I am in charge of pretty much making sure there is good communication with everybody, with all the teams, and to provide any feedback or any help that I can in any way. Whether it be mechanical, software, electrical, AI, anything, except probably art. Don't ask me about art. Yeah.
Cool.
For electrical right now, we have taken the wire harness apart, and now we are just studying it to see where everything is actually going on the cart, and just basically understanding the wiring right now. And we are also testing our e-stop design, and that's about it for what we're doing right now. Moving forward, we would like to start moving all of our schematics to Altium. Also starting to map out how we want our wire harness to look. We also want to get our battery connectors on, battery indicators going, and then also figuring out how we are going to add our braking system. So that includes adding a new PCB board, CAN, and everything, and setting that up. And then also, wait, what I need from everyone else is, I would say just come to meetings. And then, because basically in the meetings right now, we are all collectively working on just learning the harness. So that's mainly what we're doing. We haven't really switched to actually, taking anything off the cart and implementing it. So it's just really learning exactly what's happening.
Are you gonna start testing the ESAP this night?
We tested it last week. It will be set up completely next Tuesday if you want to see a example of how it will look on the cart. But the people who were here last Tuesday, we tested it and they actually built it out for themselves. So it was nice for them to learn how it would actually look on the cart. But it's already tested, so
Virtual already talk to like all the alumni for whatever. Okay,
Laura knows what's happening with the it's so I think it's times and we tested it and it's working, so I think that's what really matters. So yeah.
So you have like a circuit diagram already made for this? Well,
Yep, there's already a circuit diagram made with the new ESOP setup and the motor on there. It is not on Altium yet, it is still in draw.io, but that is something that we are working on and will we will hopefully have done by next year to have all of our schematic deposits. Yeah. We do have to make a new harness. This will not be the here anymore. So we have to make a completely new one. Um, just so everyone knows. The new one will not be wrapped. That is not accessible, so it doesn't benefit us. The new one should be something where if something goes wrong electrically, we can do maintenance to it right then and there instead of having to unwrap the entire harness to access different things and see what's happening. So that's what we're moving forward to.
I think we're
Are we gonna use a what?
The loom instead of the wrap, or are you just gonna have the wires?
Um, yes.
something like this. This is high voltage, but so we're not going to use like bright orange. But if we can find this, if we can find this material, this stuff, it's like it's a tube, and you
Yeah,
can literally just
so you get that's loom. So you get
Yeah.
classic versions of that.
Yes. And also, we are going to try to make our wiring shorter, not use excessive amount of wire in unnecessary places. Um, so it will be cleaner.
yeah.
That's it.
Okay, where are we at with software? Detecting lines. We have kind of two teams here. We have an AI team, and then we have a traditional OpenCV team. And currently, the OpenCV team, thanks to a lot of people, the person I've been seeing work on it the most is Derek. We are able to detect white lines and get polynomials, which is what we need in the software team. And we use those in our planner to know where we're at. And we can start working on that now. And then when it comes to just AI team, we're also starting to work on stuff. It's a little out of my pay grade. But those who are above my pay grade are working on this right now. And hopefully we'll kind of within the next couple of weeks we'll see progress with both of these teams and then we'll go from there. The object avoidance part is kind of outside of our scope. So the deal with the software is we want to detect lines. We want to plan a path. And then after that, we can kind of expand. And so that's where we're at. Going forward, we're just going to perfect our detector, perfect our planner. And there's going to be a bunch of little things in here. We have a new motor, so we're going to have to do some stuff with the motor. We have to do some new things with CAN and some little projects here and there, restructuring code. But the main part of software on Phoenix is detecting it and knowing where we're going and then doing that optimally. And then potentially, if we have time and resources, doing avoidance. And that's kind of our plan. And I'm optimistic. So, yeah.
So for the OpenCV team, you're saying that like you guys are just working on perfecting that right now, and
Yeah.
then are you gonna go to like testing it in sim and stuff?
So 2 weeks ago, I pretty much asked the team, hey, like right now, meaning yesterday, I want some type of basic structure that will give me polynomials. And I got that. So the reason I want that is now the planning team can work on something. They can have polynomials to work with. And so we can start working on both teams now.
Okay.
And now that I have that, we can work on perfecting our OpenCV methods and we can also now work on our AI stuff. Kind of, and then everyone can start working on their stuff.
And with the AI guys, like,
Yeah.
where are you guys at? Because I don't know.
Ali, do you want to talk on this at all, or the AI stuff, or where we're at and what you're doing, or what?
It's
What we're actually doing now, we're investigating the pre-trained models, because we do believe it's not like a specific task. So we're not detecting something unusual. We're detecting links.
Actually, can you come over here so that we can actually pick your voice up?
Okay. So I'm Ali. What we're doing now, in case no one's known me, we're like exploring the pre-trained models because, as I said, we don't see the need of pre-training a new model. But so we are a group now, so we found like 15 pre-trained ones. We're investigating more. In case we into the conclusion that we need to train one, which we'll try to avoid, we will do that. The OpenCV method is reliable somehow, but with any lightning condition changes or anything, it might fail. So we need like a fallback function, which is going to be the AI solution. So that's where we are now.
Just kind of so everyone understands how this works. Within software, you have these two. We have there it is. I'm gonna erase this. We have two methods. These two methods, and how it works is these are interchangeable. So you have your AI stuff. You have your OpenCV. These are their own different entities, and they have the same output to the detection, so that we can interchange them. Okay, forget my spelling. But detection, so that depending on which one works, as Ali said, you can fall back. Both of these have the same output, which is a polynomial left and a polynomial right. And that goes detector, and then that goes to our planner. And that is really what software is working on this year to perfect and get. Because everything last year besides this worked relatively okay. So as long as we can get this and perfect it as best as possible, we're pretty happy. Any questions? I don't think there's really anything that I need from you guys. It's more so you need from me, to be honest. And we'll talk about that. Do you want me to erase all this?
Oh yeah. All right. So basically, where we're at, there's like the high priority mech stuff that's getting done and needs to get done. There's like lower priority, smaller things, right? High priority at the moment that we're working on is the motor. Um, what needs to happen with this after? Well, I still am not fully like aware, like I don't understand completely all of the um I don't know the details regarding the motor. Um, but what I do know is if what I'm currently working on is correct, and regardless, our minimum speed for software, that you guys need to plan on is 3 meters per second. For now, that might change, but around that. So around 3 meters per second as our minimum continuous speed, and our max, I don't know. I don't know yet, but essentially, I just need from software you guys to be like working towards getting all your stuff to work at higher speeds. Um,
That
That's
should be
regarding what-
doable.
yes.
So that's about like 6.7
Um,
miles per hour. That should be doable.
Yeah, hopefully. The stuff that's going on with the motor right now is the mounting. That's the main priority, and figuring out um, what, how we're gonna run the motor essentially, and all the gear reductions, all that stuff. That's where I'm at right now, and the mounting. We're working on machining that. We're actually waiting, Zane, if you can get the confirmation for all the stuff that's shipped, because we need that soon / ASAP. Then the next thing is encoder. This is something that's more like I want to ask for your guys' feedback, at least you and you because like we have these two brand new encoders, and I talked to some people about it. These are encoders that Andy tried to look for last year and he couldn't find for some reason. But they were planning on changing the current encoder for this encoder, to allow us to go backwards, right? So we are going to replace this, and that, well, if you guys think that it's doable, that's going to require you guys to figure out how to integrate that, how to take the data that the new encoder is going to give you, and how you're going to process that, because I have no idea how that's happening at the moment. So somebody needs to look at like how the current encoder stuff, um, how all that data we're getting from the current encoder is like processed before we actually see it. And somebody needs to know like how we're gonna implement that with the new encoder if we want it to happen, right? But that's something that I want to ask you guys. I know we talked about it a little bit. And if you think it's doable and you know your way around it, then I don't see why not. Right? I don't know what are your thoughts?
It's something. parts, even if software is not able to program it into us.
But the thing is, it's a completely different encoder. So I don't know if that's
So
going to
if it's
require
not
different.
for us, what? I feel like
There, I actually don't know. It's just a rotary encoder. But I don't know if that's like I don't know. I just found these and Andy said that they ordered them. But if you want to take a look at them, because I know it's like all I know. Yeah, yeah. Well, I'm saying this one has five. That one has three. Yeah. Oh yeah, that's another reason. This encoder is very like I talked to Laura and they tried to like get another one of these encoders, but they just can't. So, like they couldn't find it. Huh? You worked with awesome, yeah. So you can definitely help us with that. And yeah, because without if the encoder breaks, then we can't run the car. So we want to have extras as well. And for some reason, I haven't looked into it. Laura said that they couldn't find this encoder. So swapping this, we have two, and at least we have one extra, and we have that capability to go in reverse. And it's also bigger and hopefully stronger. I don't know. No, one's just an extra in case this one breaks. Um, what else? So yeah, that's the encoder. Then the pressure sensor. That's another thing. For the pressure sensors, I'm still trying to like I need more input from everyone. Because the pressure sensor that you sent me, there are some two of them that are CAN interface, which is good, right? The USB ones, they work in a different way than I thought. Um, I think they pre-process that data and they just display it on a graph. Like you can download the data, you can work with that, but you can't. There's no way for you to like, translate that onto like, I don't know the software that we need. You can talk a little more about it if you'd like.
Oh, yeah.
But yeah, so I'm trying to find um and kind of like zone in on like one specific sensor to order, but I don't know. I think we need to talk a little more or just we need a little more input from software because I need to know what you guys can work with. So yeah.
Is there analog to digital?
Yes, it is. What was the problem with the USB? Was it an electrical problem or just software?
No, I don't know. I need to talk to the company because the way that it says on the data sheet or the website in general, the way that it's set up is that the information that we're getting has to go through the specific software that we have to download from their company. And all it does is it displays the data on a graph and it gives us like all of it, like our tabular like data. And we just the only thing that we can do with that is save it, like export it as like an Excel file or something. But there's no way to use that. I think
Why not just use an analog?
that's what
Why?
that's what we're
What's the purpose? No, I'm not judging. I'm not.
there is one that sends analog signals through USB. And that's something that we
Why even use USB yet? I mean,
well because it makes it easier. We just
Does it? That's
we
enough.
plug in the sensor from there directly to the PC instead of going through our
yeah,
micro
but now the PC requires a driver and something specific to the software. If you did an analog,
yeah
you could replace the pressure sensor with any other pressure sensor all day long, and you would
yeah
and your system takes an analog input, which is much more normal than a USB input.
yeah and so I was trying
You're
to
not going to find a USB device in a USB pressure sensor in a production car, right?
The signal shape for each sensor is not the same. So who tells us how to convert this like electrical signal into a pressure value is the manufacturer. So what he's looking for now is like a sensor with a manufacturer that can provide us with the code or the SDK for this.
Real time pressure data, like that's fast changing,
yeah
or are you just trying to get like what is the current pressure?
no we're trying to get pressure data because that's how we're going to use that's the feedback that we're going to get in order to control the linear actuator because the way that the linear actuator was getting fine tuned to like see how much like the range of how much it extends versus it's not extending. That was they tried to do that like calibrating it by hand essentially, which resulted in the brake line like
Yeah.
what's it called the brake line was like breaking all the time.
Yeah,
Well,
it's
like
breaking.
over pressurized.
Okay, so then that needs to be tied together then. What, like,
so yeah, we
one
need to,
person should be writing a module, software module that's gonna handle all this in one thing.
yeah.
But we prepare that's what is created by the manufacturer. So that's what he's looking for now. Like that sensor with its own code. So we don't need to write the code for the sensor. Because sometimes it's easy, sometimes it's not. That depends on the manufacturer himself.
I'm talking about the whole system, right? Now he's using that to then use feedback to the actuator, and he's gonna like
Yeah.
so it doesn't. I mean, all you need is this analog input. I don't know.
No, yeah, that's why I'm looking into it. That's why I want to know what is useful, what isn't
The
useful.
budget.
Like I'm trying. Well, that's another thing.
But that's what I'm saying.
Versus like
Look at a pressure sensor that Ford uses and you go to the dealer and buy for $12. Like if that
Yeah.
works with a little extra code, that's the way to go.
Yeah.
You can always get $1,000 sensors that do everything. Right?
yeah. So my original thought was just if it's just an analog input, we have like a microcontroller here, and just plug it in and use that. Like I don't know how that works, so that's why like I'm trying to like figure out what we need. If we need it to be like CAN interface like built in to the pressure sensor, or if that's something that like straight up just like a voltage output.
The software, I don't know. If software needs to know what's happening with the pressure sensor, we probably because that's how we're gonna get it. We need someone to communicate it back to there. But
Yeah, but if we so the microcontroller, if we like say I don't know how, but like you could read. Yeah.
saying if software needs to know exactly what's happening with the pressure sensor, we do have to figure out a way for it to communicate back to the receiver.
Yeah.
Or the computer to communicate to them. So
I mean,
we just gonna have to look
But
at it
so,
together.
but
so I mean, for that, do we know how the pricing, I mean, the actuator works? Do we have a board for that?
We have it somewhere. I don't know where, and that's something.
So if we know how the linear actuator can be controlled, like what are the inputs that we can give, then maybe we can use the data which we are getting from the sensor. Okay. Yeah, exactly. Control the actuator. The pressure and the actuator.
The pressure sensor, right?
No, the actuator.
Back,
That's what it
yeah,
is.
that does use.
So yeah, it uses scan.
Yeah.
So it takes some input. If we know the input which we are giving, then maybe we can interpret it from the output. Yeah. I mean that's what we usually do in the labs. It says activated user scan.
Yeah.
are you trying to reverse engineer the output through the actuator?
Without
What are you trying to do? Trying to reverse engineer the outputs to the actuators?
yes,
Because that's in code, right? There should be nothing to look at.
but we can control activator using a code. Any but if they have a code, then they should be getting some input.
I don't. Do we have a code for this?
Yes.
Right?
Yeah.
We were able to control it at some point. I don't know what the code is. Someone needs to find what that looks like.
Yeah.
Figure that out. So yeah.
I haven't touched this before, right? So I didn't know this. Now that I'm hearing about it, I can look into it.
I'm not sure. What the sensor would use to zero. It sounds like we need to add it to AMP. So I'm figuring it out. But
You guys seem to have a still lifting.
I mean, because we're not only using
That's what we're using. That's what we're doing with the encoder.
you know,
That's yeah, we're plugging it into these microcontrollers, which then goes to the CAN board. So that's how we're doing it. If we already have that set up, then can't we just add more inputs to that board that then get transmitted through that CAN board? I don't know how that works.
board rubber cam. So that's where the design. Yeah, because we do are already pretty unique. We have animal transport, we have digital response, things.
Well, the households for me is everything that was so soft. Well, I didn't more. I didn't think much soft for people. I have music to join them. So if I ask them what three things, what it is, like what it looks like,
Yeah, so you need to figure out what our current encoder codes stuff looks like, how it's processed. That's one. Then figure out how the linear actuator code is processed. That's another thing. This is just a question that I can ask Andy or Laura, whatever.
I was thinking of this from a traditional ECU point of view. But clearly, that's not what's happening. And so, yeah. Actually, yeah, I'll show
You're right. You're right. I want to talk about motor control, like fid tuning. Somebody needs to take that responsibility on.
Where's the problem? Back in, and then we'll get out of here.
Okay, yeah. So
With the new motor, software wise, what we need is somebody or a team to look into the actual control of the motor, like the pid tuning. I don't know if anyone has experience with like, yeah, okay, perfect.
This is I respect the ID tuning on the regulator side, not on the motor side. That's totally why.
Well, yeah, okay, but I mean like replacing the motor, like what I mean by that is like not the motor, but like just in general, integrating all the things that we need to do with the motor and the motor controller. We need somebody to look in. We need somebody like prepared so that when we get the motor and we set it up, they can figure that out, and we can configure everything, tune it the way that we need to, so that we can start testing. Because I don't. I mean, the competition's in June, and we're gonna pretend like I don't know how many weeks in December. It's like 3 weeks in December that don't exist, because of break, right? So we only have we have a good chunk of time, but we wanna get this like
Yep.
done quickly because of all the rule changes too. We want to be able to test things as soon as possible. But yeah, that's basically all I want to say.
Cool.